On problems 16 through 18, our goal is to convert from rectangular coordinates to polar coordinates. I found that it's really helpful to first sketch where the point is just to get an idea of where your end result is supposed to be. And so that's what I did first. So for number 16, negative 3, 3 is going to put us in the second quadrant. First thing we want to do is find the r value, which we can use doing a Pythagorean theorem. And so that gives us a result of 3 root 2. You can also leave it as the square root of 18. I have no preference as to whether or not you simplify your radicals. Next thing we want to do is use tangent in order to figure out what angle we're going to. And so if we take the inverse tangent of y over x, your calculator is going to give you a result of negative 45. And the reason for that is that the calculator isn't necessarily sure which quadrant you're talking about as far as signs. You know, tangent can be negative in the fourth quadrant and in the second quadrant. And so that's why it's so important to sketch your point first so that you know which quadrant your answer should end up in. Negative 45 degrees is in the fourth quadrant, so you want to find the matching angle that would be in the third quadrant that would go along with that. And so that angle that would match with that is 135 degrees. On problem 17, if you sketch the point, you'll find that you probably don't need to do any calculating. The point lies on the negative y-axis, and so it's easy to tell what the r value is. That's just going to be 4. And if you look at your unit circle, it's also easy to tell what that angle measurement would be, 270 degrees. And so without doing any calculating and just by sketching, we can determine what our polar coordinates should be. On number 18 again, it helps to sketch the point first. In this case, the point ends up in the fourth quadrant. I'm going to find my r value by using the Pythagorean theorem. Completing the Pythagorean theorem gives me a result of the square root of 5. And then we'll use the inverse tangent again to determine what our theta should be. In this case, our calculator gives us a result of negative 63.43 degrees, which in this case is accurate. We do want our angle measure to be in the fourth quadrant. It is preferred that you express it using the positive degree measurement, though, as opposed to the negative degree measurement. So if you add negative 63.43 to 360, then you'll get 296.56 as a result. And so we're going to use that angle measurement for our final answer. On number 19 through 21, we're going to be using the same type of process, but now in reverse. We're going to be starting with polar coordinates and working back to rectangular coordinates. It still helps to draw a sketch of where your point should be so that you know ahead of time what the signs of your result is going to look like. In this case, negative pi over 4 takes us into the fourth quadrant, and so I know that I'm going to have a positive x value and a negative y value in my result. X value is found by taking the radius times the cosine of the angle. Y value is found by taking the radius times the sine of the angle. And my final result for that is going to be 1, negative 1. On number 20, radius of 6 and an angle measure of 240 degrees, that takes us into the third quadrant. We're going to use the same calculations in order to find the x and y values. And so there's our final answer. Both the x and the y values are negative. And finally on 21, going 5 pi just means that you're going the distance of pi 5 times. You can also think of it as going a full revolution of 2 pi, and then another revolution of 2 pi, which would be 4 pi, and then half a revolution, which takes you to 5 pi. And so that actually puts our point on the negative x-axis, and so we don't need to do any calculating to figure out where that point should be. Our radius was 5, and we know it's on the negative x-axis, so it needs to be negative 5, and we're not going up or down at all, so our y value for that will be 0. On numbers 22 through 25, we're supposed to be combining vectors. It's up to you if you want to use the grids to sketch to get a visual of where the vectors should be. I'm going to go ahead and use the patterns that we found in class and just combine them algebraically. And so if we're going to sketch or determine the component form of the vector 2m, we need to just start with the vector m and double the components that are a part of that vector. So our final result for that would be -4 and 6. And writing that in unit vector form, -4i plus 6j. I is the unit vector for the horizontal component, j is the unit vector for the vertical component. Looking at the other side, if we're going to combine vectors v and z, again we just need to combine the corresponding components. So the two horizontal components, 1 and 3, combined to be 4. The two vertical components, 4 and -1, combined to be 3. And so there's the format for our final answer in component form and in unit vector form. On number 24, we're starting with vector m and subtracting vector z, which really means that we're doing the opposite of whatever vector z tells us to do. And so the opposite of vector z means a horizontal component of -3 and a vertical component of 1. And so if we combine the positive m with the negative z, then that gives us a result of -5 and 4. Finally, for the last combination, we need to take the opposite of v and double it, and then combine it with the vector m. And so when we combine those two pieces of information, that gives us -4 and -5.